Good morning, everyone. We'll start in just a second. Let's let all of the attendees pour into the room. Just give us another 60 seconds. Okay, that looks like everybody. So my name is Michael McClellan. I'm with Levine Electronics and Electrics. Thank you so much for attending another lunchtime webinar. Levine Electronics and Electrics is a manufacturer's rep firm. We have a power division and a controls division. We believe in giving back to the engineering community, and that's what these webinars are all about. Hopefully you'll find them helpful from a technical standpoint, and maybe commercially you might learn about a new product you weren't aware of previously. Your phones are muted right now. We are in standard presentation mode, and what that means is that I can unmute your phones. So we would love for you to ask questions. There's a couple different ways to do that. There's a button on probably the lower right hand corner of your screen, and you can press that button and type in a question if you don't like hearing the sound of your own voice, or you can raise your hand using a different button, and I can unmute your phone and we can engage in a discussion. So we're very lucky to have with us Jay Johnston. Jay knows his way around the electrical industry. He's been in the business at least 26 years. And I think he'll tell us about a little of that. And he's going to tell you today about e-houses and why they're used, and some certifications that could be obtained from third parties. And now I'm going to turn it over to Jay Johnston.
Thank you, Michael. I assume you can hear me. Appreciate everybody attending today. Try to make this pitches and discussion as lively as possible. Normally these things for me are purely commercial, but I've tried very hard to make this somewhat technical to show you how we build buildings. I also have Logan Martin with me. He's our application engineer, and if you end up inquiring with us on a project, more than likely he's going to be the one working on it. He handles a large majority of our building opportunities. Also have Delaney with us as well. She's our marketing assistant, helped us put together a presentation, have her in here to just get some experience. So really what I want to do is just give you a quick overview on our business to kind of give you some confidence that we know what we're doing. Then I'll talk a little bit about our building product and how we build that product. We build the product a little different than most manufacturers, and I'll explain that. And then when I sat down to interview the engineering and application project team, most of my role in this business now is oversight. And so sometimes I lose the minutia or access to that. And so the thing that I'll end up talking about are a lot of the codes and certifications, state programs and things that are happened to our industry involving this product line that we did not see 10 or 15 years ago. That is a lot more prevalent and can impact projects. So that'll be the basis. It'll be I usually like to say it's very informal. So as Michael said, if you have questions, feel free to pipe up. Logan might talk over me as I'm missing a point that he knows better than I do. So hopefully that won't be annoying to you guys. And with that, we'll just get started. AMR Pemco, we've been around since 1960. We started our backgrounds in the underground mining industry and building electrical distribution equipment. The reason that we build buildings is because we needed to diversify our business going back to the 80s and 90s to stay in business because mining markets were declining. So we're very interesting from a building manufacturing standpoint because we're an electrical company by nature. Most building manufacturers are just purely mechanical and structural and building enclosures, where we got into the business to populate electrical equipment and apparatus into the buildings. And I'll talk a bit about that more later. We also build dry type transformers. Sorry, I'm on the wrong screen. We also build dry type transformers and custom switchgear as well. So this gives you an idea of the world that we're in with the different codes and certifications that we participate in. The ICC, that green box there in the top right, that's primarily the area where we're going to on the building code that applies, but you can see many of the other codes that apply that we get into that apply to buildings, NFPA, NEC, sometimes the IEEE, and then AWS, the American Welding Society. It's worth mentioning that we're an ISO certified company, and we do have CSA and UL files active. Okay. Again, this goes through core capabilities. I won't spend a long time on this. Obviously, we build buildings. We've been doing that since the early 90s. Many different industries served, from mining to power generation to utility, transit, nuclear, wastewater, and then what I would get into all your general industry classifications, paper, metals, gas measurement. We do a lot of natural gas buildings, et cetera, et cetera. The other thing about our buildings is that we're putting all different types of things in them all the time. We're a very custom build to order type outfit. So we're doing a lot of switch gear, drive integration, transformers, control systems, pumping systems, chromatograph systems, and like I said, we do have that expertise electrically to install that. We both have electrical and mechanical teams in-house to look over our projects. And as I said, we built dry type transformers, and then we do all of our building designs in 3D modeling, a solid edge modeling platform, so we can do renderings and step files to publish to our customers, which actually help in the approval process. So you'll see some of those renderings later on in the presentation. So this is to start out, just a general overview of our building. Kind of shows an example. This is a rendering off our 3D modeling software. We'll get into some of those cutaways more in detail, but some of the background on the buildings is that we're vertically integrated. So we design and construct the building. So essentially we buy flat steel, make it into a building, buy structural steel, make it into a base. And I'll explain that process a little further. All our buildings are built in accordance with the IBC or the International Building Code. So if you have a project, you bring us a location, we look up the IBC and we design to that standard, to that location. A lot of our building design standards apply to multiple locations, so we're not changing the designs every time. All of our fabrication happens in-house. I'll explain that further too. I'll get into explanation on our wall, roof, and base construction as well. So that just gives you an example. We'll get into that in more detail. Another rendering that we have of just a different size building shows multiple air conditioning options there, pedestals, steps, platforms, things of that nature that you might need as accessories to go with your building. The other thing about us is because we're a custom house, we make all our doors in-house, and so that's handy for you guys when we get into custom door sizes for equipment access or personnel egress, either one. We do all that in-house. This just shows you how we handle the buildings at site. I mean, at our plant. That blue gantry crane in the picture is at our facility. We own that 88-ton gantry crane. We have a little brother to that as well, a 35-ton crane. So we can get into some larger, heavier buildings. That building in the picture weighs about 110,000 pounds. It has a big compressor drive in it. for a gas application. And then the picture to the right is the sister building to that building. The one on the left is a single building, and on the one on the right is a multiple piece building. The drive was too large to get into a single piece building, so we did shipping sections, and that just kind of shows it being installed at site, gives you an idea of the size and scope of them. The other thing that we do that might be unique to other folks is we do floorless buildings. We come from the mining industry, so our design background is pretty robust. And so because of the robust nature of the buildings, which you'll see, we're able to build many sizes and shapes with what we call DOBIs, or deposit on base enclosures. And they're basically floorless buildings. They're essentially the same construction without a base. They're going to come with the same fully featured equipment as far as HVAC, lighting panel boards, control transformers, lights, light switches, receptacles, et cetera, they pretty much come assembled and finished, pretty much as the rendering shows. And the idea is if you have a project that's on a tight schedule and there's not time to send the equipment to us to put it inside the building and send it to you, we'll arrange from a project standpoint to have the building go to site, be mounted on a concrete pad or a steel mezzanine, something of that nature, some foundation, and then the building will meet the equipment in site. And there's a picture later on in the presentation that shows that as well. So this helps with on-site time, minimal on-site time. Generally, you have a crane there for the equipment anyway, so the crane just lowers the building. You secure it to the foundation, and you move on. So wanted to speak a little bit about the actual construction of our buildings. It's a little different. It's similar, but a little different to most of the manufacturers in that modular building space. Generally, we're heavier construction than a lot of the industry. And again, I think that comes from the mining industry. So let's talk about our walls first. We really have two standard wall constructions, a 16 gauge overlapping or interlocking design, a 12 gauge seam welded design, which I'll talk more about. That seam welding, I wouldn't call it proprietary to us, but I have not seen that capability within another manufacturer, and that helps you in some applications, which I'll discuss. And then we also have an 11 gauge building available. The 11 gauge is a standard gauge in the transit industry, so that's why we have that available. So this shows a rendering of a standard wall panel with our cross bracing for strength and wind loading. You can also kind of see nested in the corner some additional bracing for strength, but essentially all walls are bent into a pan and then bolted or welded together for strength. So we're a frameless building. We have no structure added in addition to our walls. All of that strength is built in the wall panel itself. Since we're custom, we have various wall heights available, 110 inch and 112 inch, or 110 inch and 120 inch are standard. And then we can do single wall heights up to 144. In full disclosure, we have the ability to go higher than that, but that's rare due to shipping restrictions on height. Okay. Most of our insulation systems is a standard low-cost fiberglass batt product. Typically R3, R13 is standard. With energy efficiency codes, which I'll talk about in a minute, we're seeing some need for additional foam board insulation in addition to our cavity insulation, which I'll show you some renderings on. And then on the interior of the building, you have many options. Standard is a painted 16 gauge cold roll interior skin. And then we also have options if you have a fire rating that you need to meet to put up fire rated OSB board, or if you're in a grounding situation, we can also put some FRP material around the interior of the building as well. We've done gypsum board in some cases, wood in some cases. So there's many options based off your customer specifications and site requirements. This gives a top-down view of each panel, just to give you an idea of the difference between the 12 and 16 gauge product. You can see how the 16 gauge is built with an overlapping design. Generally, that's a 16-inch nominal panel that's bolted together, and then that overlapping prevents any weather ingress. And then the 12 gauge panel, which is probably our more standard product and the one we've been building since the 90s. Even though it's not shown on this drawing, imagine a bead of weld at each corner. So we have an automated steam welder that welds all of our wall seams solid together. So you have a solid weldment on each wall panel, and then welded at each corner. And so you have a very strong enclosure that helps you with all different types of seismic and wind loading requirements. The other thing when we build our buildings is we generally build the base, put the equipment down, build the building as a shell, and lift the shell in one piece, similar to this picture here. We'll do this application in our shop time and time again. So that way we can do things concurrently. We can install the equipment on the base and then set the building later, and it cuts our cycle time in our buildings. This is just a rendering. I wish this circle was blown up a little larger. I don't know how well you can see it, but this gives a good idea of the wall construction with the interlocking design. Picture this cavity with R13 bat insulation. This particular customer needed OSB for fire protection and then additional efficiency rating. So we put foam board on the inside and then an FRP material. This is a gas application with gas measurement and chromatograph equipment in Pennsylvania. So it gets very cold there. And so they wanted the additional insulation in the wintertime to cut down on the need for heat. That gives you some of our design capability. It's a small building. Good illustration though. As we move into our bases, we do all self-supporting structural steel bases. They're all designed and welded in-house, all welded construction. We'll make the base based off the requirements of the equipment inside of it, the seismic conditions at site, and transport conditions getting from our factory to your site as well. So we'll use I-beam, C-channel, or tubing to achieve all that. We have many different sizes and shapes of bases. We can probably go up to 15 wide, but 52 feet long in one piece. That dimension is restricted on shipping going any larger than that. So that's our single largest one-piece building. Anything larger than that, we get into multiple sections. Floor decking, we'll use 1/4-inch steel as a standard if nothing spec'd. We also have all types of floor options, diamond plate, aluminum, grading, if you need rubber mat, et cetera, et cetera. And then we can, in some cases, do computer or access floor. So you can do in-floor wire and cableways, and we've also done busways in the floor. We do all our own copper bus fabrication. So sometimes internal to the building, we'll do bus duct from one side of the building to another, which is a value add that our customer doesn't have to go source that bus duct himself. Also,
hey,
these
Jay,
bases.
a question came in. Question says, do you have the ability to provide buildings with heavy equipment loading?
Yes. Heavy equipment loading is relative, but yes, this building here in the picture, I think that drive weighed 43,000 pounds. Okay. And then it had another bus assembly that weighed 8,000 or 10,000 pounds, which we hung off the roof. So yeah, heavy equipment loads, we can handle that. So this was a 33,000 horsepower drive, and it weighed, I don't know, somewhere in the neighborhood of 50,000 pounds. So that's just one example. That's a good question though. So you can also, in many cases, I've shown some of these buildings elevated, especially in the southeast where I think most of you guys are. Heat and humidity is an issue which could cause corrosion on the underside of your base, and so sometimes we'll suggest a closed cell spray foam insulation. which we can build. Really, it's more for corrosion protection as it is as much insulation value, but that we can apply that at R7 per inch pretty easily during our base construction. And then our standard deflection rate's L over 240, which is pretty standard in most specifications that you see. The other detail that I didn't show here, let me see if I show it in another rendering. Sorry about that. Lifting lugs right here. We make and certify all our own lifting lugs. So that heavy equipment question would apply that we have, I don't know it right off the top of my head, but we have a rating for that lifting lug. And so depending on the weight of the building, we would apply the appropriate number of lifting lugs, which you can kind of see here in these renderings. This rendering here is this building here. So that kind of gives you an idea. You can see the lifting lugs there on the side. Our gantry crane, we could load it with 4, but for the site, we offered 6 lifting points to keep it more stable. So that kind of pertains to that heavy lifting question. We'll move on to we've talked about walls and base, now we'll move on to the roof. Our roof construction is probably the most unique in the building space that we've seen compared to other vendors. A lot of vendors do like a standard standing seam roof where they have a roof structure and then a ceiling structure, and each of them have a loading. Our welded truss system is a singular structural member. And so the roof and the ceilings share the same structural member. It is very strong and it is very robust. So we'll fabricate 11 gauge trusses with 7 gauge gussets. You can kind of see a cutaway there. Then they are all welded into a weldment with a soffit that you see on the outside, and then sheeted with a solid welded 316 as standard. I haven't verified the 316 with engineering, but I'm pretty sure that's what it is. Obviously, we can vary that if we get into roof loads. So this roof design cures a lot of ills for us in the certification processes from a seismic and wind load standpoint. It also allows a heavier inherent roof loading. So if you need to put air conditionings on the roof or resistors, or you need to hang cable tray from the ceiling, busway from the ceiling, it just gives you a lot of more flexibility in your applications on what you can do in a standard design. So we'll do flat roofs for interior, single slope roofs, apex roofs, gutter systems, just really design it for the application. So interior roof sheeting is the same 16 gauge cold roll as we talked about before, but of course you have all kinds of options if you need those. And then the lights and everything are just located on the interior of the building. And then fiberglass is standard is either R13 or R19. Some specs in some states require R19. And generally you have enough cavity in the roof structure to provide that. Thought I'd mention paints and coatings. All of our paint systems are wet paint. You know, we're generally painting large weldments, so powder painting isn't really applicable. We do have a powder painting booth in our facility for small panels, doors, things of that nature, but all the buildings are wet painted. This is kind of a standard specification. That's one thing I should have led with, Michael, is we do have standard specs available that I can publish to you that you can send out to people that kind of mimic this presentation in what I would call a technical format that goes through our construction methods. So I should have mentioned that earlier. But when we were sitting down, we thought maybe we should tell you how we coat them. We clean all structure at SP3, which is a machine tool cleaning standard. Some specs require sandblasting, which we will outsource, but generally we can get our customers to accept that SP3 standard. And then we solve and clean all the structure prior to paint. The sheet metal is a little more in depth. We generally do a phosphatizing process, which is a steam cleaning with hot water and a chemical called Criscoat. We've been using that for quite a while. Generally, it cleans all oils or contaminants from the metal and then places a profile on that metal to accept paint. And then we also solvent clean and fix any imperfections in the steel prior to paint as well. We apply all our coats in painting all coatings in a controlled environment. We have a large 50 some odd foot paint booth. So we can heat the booth up for certain epoxy paints, or if we need to cut the humidity in the summertime, we'll do that as well. So all of our paints are either an industrial enamel or a 2-part epoxy. Most of the time, we're going to recommend a 2-part epoxy system. Generally has a 20-year life, 25-year life. We primarily use Lugs as a standard paint, the old DuPont, but we have some other paints in tow for special applications, zinc applications, zinc primers for corrosive environments. We do a lot in the gas space, so we have to be able to paint those corrosive environments pretty well. And in the Southeast, if you have any salt or coastal environments, we can handle those. And with our Exalta paint system, we have a 2,500 and a 5,000 hour salt spray certification with their paint system. And the 5,000 is pretty extreme. You only see mostly 2,000 hour tests performed in most cases. The other thing I want to get into with this is, how long you want me to go, Michael?
Well, most of the hour.
Okay, no problem. I don't think I'll need to abbreviate, but I will if I need to. I didn't know how much time you wanted to leave for questions. So when we sat down with the team, one thing that's become more prevalent in our building and project process are codes and certifications. Okay, so I wanted to talk about this in 2 separate areas. One is pretty standard on a lot of buildings that we provide. I'd say, what, 90%, Logan? Our customer is going to require structural certification and stamped drawings. And to the folks on the phone, that's probably familiar to you guys as well. So I thought I'd run through this on one slide quickly of things that you get with the structural certification and stamped drawing package. You know, first of all, as I said, we're designing for a specific location per IBC. So, you know, for example, you pick a spot in Florida or along the Gulf Coast, you're in a higher wind load, we're going to take into account those wind curves. I know this might not pertain to many people on the phone, but we have more buildings in California than any other state. And the reason for that is our robust design plays very well in the seismic conditions out there without having to do too much else in our building to meet those requirements. We also have a lot of buildings in the lake area, the Great Lakes area, because our strong roof, we get into snow, you know, heavy snow loads. So we're going to take those factors per IBC into account. And then our structural engineer will analyze the seismic, wind, snow, equipment loads. Then you get into mounting methods where you're on pedestals or mezzanines or concrete pads, gravel, etc. That'll go into each certification. When you do these certifications, you're going to get certain deliverables as a standard. The first is a load table, which is, many of you guys probably, that'll sound familiar. You need that for your foundation and civil purposes, so you can confirm and plan your pad or mounting location. So the load table is going to include center of gravity, all your approximate weights, and recommending mounting locations, so your civil team can know what to do to build a pad. You're going to get a recommended lifting plan, which you're going to need for all your crane and rigging people. And then you're going to get a full set of stamped drawings. The stamp packages are 100 pages. Yeah, I mean, they're large packages. So you'll get full transparency on the package, on our building design, all the finite modeling that they do, all the calculations that they do. They just don't give you the building drawings and stamp them. They give you all the calculations that go behind those drawings, and then we'll deliver that in a package, and that's our standard as a stamp package. And then, of course, the stamp is based on the state. We currently use a structural outfit in California on contract. We've had a relationship with them since the late 90s. One reason we outsource that is they've probably stamped up to what, 30 states for us?
Yeah, they have 37 on retainer.
Yeah, 37 states on retainer. So that gives us a lot of flexibility for the different locations that we're going to go into. So whatever state your project's in, we can probably apply to that. Okay.
Hey Jay, a question came in from a design standpoint. What do we do to the walls when a high wind load is required?
We had I don't have a slide in this presentation, but I'll show you this slide here. This design right here is probably 125 mile an hour wind load out of the box per se, without us having to do anything. That is also dependent on the size and scope of the building. Larger buildings, the walls have to be stronger because there's a larger profile. But on most buildings, I would say 12 or 14 wide by 40 feet long and smaller, our standard wall panel will work in most wind load applications. So what we'll do in a high wind load application, for example, we have a number of buildings in Miami-Dade County, and that's either 156 or 165 mile an hour wind loading. I'm dyslexic there. I don't remember. 165. So what we'll do, Michael, is we'll do extra gussets in the corners. We'll do some extra bracing in the top and bottom, and that's for mechanical strength as it secures to the roof assembly and the wall and the base assembly. And then occasionally we'll add some additional cross bracing in the wall for that additional wind load. We did one project with FP&L in Fort Lauderdale, and it was on an excitation project. They required 200 mile an hour wind load, and it was basically a steel vault. It was ridiculous. So we did extra steel bracing, and then one of the other things we did was we went with a heavier interior skin with a certain type of fastener that gave it some rigidity once it was all assembled. So it kind of depends on the wind load area, but that's a quick answer on how we would tackle that. Our seam welding.
What is the maximum wind load that we can design to?
The highest we've seen is 200 or 220.
210, I think.
Yeah, don't quote us on that, but in that range, 2 to 210.
That covers about all of continental U.S.
Yeah. Those were pretty special applications in Florida and the Gulf Coast primarily. When you see accelerated wind loads, they're mainly in the 135 to 155 range. And we've built several different buildings in that, configurations in that application, anywhere from 8 by 12 to probably 12 by 45 or 14 by 45. So did that answer?
You had mentioned Florida. Do you guys, I understand that there's some interesting requirements for Florida. There may be even a approved vendors list. So are you guys pre-approved with the Florida Department of Community Affairs?
Dude, you're setting me up so good. You just like segue master right there. So I'm about to talk about that next.
I've been called worse.
Yeah, so I did this slide, structural certification and stamp drawings, because we've been doing that for years, okay? And that's just good engineering practice, okay? What we're going to talk about now is something that's new on the newer that is affecting cost and or timing on lots of projects, okay? And that's when you get into state programs and modular building inspections, okay? So that's exactly the question that you're asking. So a lot of states, and they're all jumping on board pretty quickly. Let's say the first ones on board were out west. So essentially they're requiring a certification of a modular building. So our equipment enclosure for an industrial application is getting the same consideration as manufactured housing, okay? Or what we would call a modular built house, where the dining room comes in on a truck and the bedroom comes in on a truck, and the whole house is assembled together. So in many states, our industrial building is falling under the same criteria, okay? So these states have set up a program for building inspectors, for third-party engineering firms to come in and do the inspection on behalf of the state for whoever we're working under, okay? This is lightening the load on the given states not to have to hire so many inspectors. Plus, they get to charge all the building manufacturers either on an annual basis or a project basis for those certifications, okay? So I was going to take a minute, if that's okay, to kind of talk about that process and the cost involved and the time involved. So as you guys get into projects and specifications, if you can seek exemptions or avoid the state certification process, that'll make your projects cheaper and faster, okay? I don't know whether this is a good point to enter this or not, but when we first got into our very first one was in Colorado, and it was in the 2004-5 timeframe. Basically, our building was being considered as the same thing as a hospital, a prison, a school, a commercial building. So all the energy efficiency standards that were applied to that construction got applied to our building. And we were building a building with a drive in it with a bunch of waste heat. And so the code and standard was in direct conflict with our application. We were wanting to use lots of air movement and air conditioning to remove the heat from the building. And the standard was calling out to put more insulation in there to hold the heat in, as if it's cold in the wintertime and you want the room to stay warm. Well, in this case, we would need the waste heat to exit the building so the equipment continue to function. So we've kind of learned how to fight those battles, and I'll go through these slides. That's just one example. At this point in time, there is no category for equipment enclosures or e-houses in these state programs. Okay, and it's kind of good that that statement there on that second bullet point about how the high insulation R values are meant for human occupied spaces and not equipment rooms. So we're starting to see some movement for U-class or utility and S-class or storage for some equipment, but you have to do a lot of due diligence. If you're not using us as a building provider, you need to be pushing your building provider on what they know about these state programs. And if these state programs are certifying the building with all the equipment installed, one of the shortcuts that building manufacturers take is they get their building installed, but if you have a drive or piece of equipment installed, your equipment is not certified within that building. That's one gotcha that you need to look at, okay? So, sorry, I'm on the wrong sheet. This gives you a quick list of all the states that require certification versus states that don't require certification. Some of these states have programs like West Virginia that they don't enforce, okay? But that is a current list as of now. And then you can see what the pending ones are. We built a lot of buildings in Pennsylvania, and right now we're skirting that. But we think that's about to end. So on this list, to answer your question, Michael, we've done Alabama, Arizona, California, Colorado, Florida, Georgia. No, we haven't done Georgia, have we?
No, we have
Georgia,
Kentucky,
Louisville,
Maryland.
I'm sorry, Louisville, Louisiana, Maryland, Massachusetts,
New York, North Carolina,
New Jersey,
Dakota,
Ohio.
South Carolina, Tennessee, Texas, and Virginia.
So we've done a lot on the list. So I guess that would answer your pre-approved question. Okay. The other thing is even if we're not pre-approved, we're going to go seek the guidance from each state to try to meet the criteria for those states. Sometimes if you're not pre-approved, though, to your point, the timing for the certification is a lot longer. So generally, when you get into state programs, some of the things that are required, you got to have a manufacturing facility quality plan. Unfortunately, the state by state requirements are not the same and they vary greatly. So one standard quality plan doesn't work, unfortunately. So we have to tailor that for each state. Then they inspect your facility to make sure that you are who you say you are and that you can build what you say you can. So there's an inspection part there. And then you have, that's just in kind of the standard qualification. And then you get into each project. They're going to look at all your drawings, plans, structural drawings, certifications, both mechanically and electrically. There'll be a comm check, which I'll talk about in a minute. And then you get into the whole inspection process that is in process and final. And so during that inspection, they'll look at your weld quality. Does your construction meet your drawings? They'll check you for all electrical connections, NEC compliance, and PA compliance. Does your HVAC meet requirements? Insulation systems as advertised. And then generally for the final overall inspection, they'll place a certification or a sticker on that building. So when it gets to site, then no additional inspection will be required. That's not always the case. Sometimes they do inspection, but it's not required. So when you receive the building, it will be certified. So I kind of went through this before. This is somewhat redundant. Base construction, wall construction, roof construction are all looked at. Insulation, HVAC, electrical. Sorry for the duplicity there. Let's talk about the impacts as we get into, as we're all doing projects together. Most of the, as you asked, most of these state programs require that we're certified ahead of time. We can tell you upon quotation whether we're in that certification program or not. And if we're not, we can tell you how long it'll take for us to get certified. And generally, we eat that cost to be in that state program. That's part of its cost of doing business. Many of the state programs require each project to be reviewed. Colorado is probably the worst. I know you guys don't probably do a lot in Colorado, but that's just an example. They require a minimum of 30 days for each packet process. So that's a week, that's a month that you're killing after you've had your building certified by a structural engineer and electrical engineer. Then they have 30 days to question you. Many of the states also are very in a commercial or residential mindset with Romex wiring, wood studs, things of that nature, and there's generally some explanation for the steel building and equipment enclosure model. That still happens on a pretty regular occurrence. And then I listed a cost. We listed some costs there for you guys so you can be expectant of what to see from your vendor base as to what those certifications cost, whether they bury that in the price or we always show these costs separate so you understand what those are. And generally we apply either no or very little markup to these as well. So you have facility inspections, you have plan reviews, and then you have building inspections. And so it is not uncommon to see $10,000 to even $20,000 on projects be spent on just state certifications. And if you're in a $500,000 building with a bunch of equipment, that's not a big deal. But if you're buying a $60,000 enclosure, then that could be very impactful to your purchase decisions and your project, okay? So with that, we try to give our customers some advice on how to seek exemption for these houses. Some examples for exemption that we've seen, all transit authorities are exempt. Most utility substations are exempt. Most utility power generation facilities are exempt. Believe it or not, even though most municipals are exempt from state certification, which is kind of ironic. But you'll just have to look in each state or call us and we'll do that due diligence for you. We don't have a problem, finding out what's required. So we've given you some examples here. I'm sorry?
Yeah, a question came in. It's kind of interesting. Can your buildings be expanded in the field if we need to add more gear in the future?
Yes, the short answer is yes, we can do that. The long answer is a pain in the ass. So pain in the butt, pardon me. But yes, I mean, essentially what we have designed buildings in the past where we have a flush end with no overhanging soffit, a removable end wall. And then we have designed for the base that you'll basically buy a second building and set it in beside it, and it'll bolt together, and you either discard the existing end wall or use it on the expanded section. And we've done that a half a dozen times, probably over 25 years. We've probably planned for it 3 dozen times, if you know what I mean. But that is something that we can design for, yes. The pain in the butt part is the structural certification of, knowing what you're doing and how you get that thing certified. Some states require you to do the whole building plan and get the whole thing certified. Some states require to do 2 certifications, one for the existing, one for the future. So you just kind of got to walk through that and see how that goes, but it is a possibility. Okay. So I'm pretty close to finishing the technical information. I'll finish running through that. And then I just got some pictures showing examples. As I was talking about exemptions, we're giving you some examples of how to do some exemptions. Full building exemption, there's a section which we have an example of in this presentation. In a partial exemption where you can be granted on your energy envelope. And so basically you're looking to reduce the required R value in your insulation that's trapping the excessive heat from electrical equipment. And I mentioned that application earlier. And we have pulled that partial exemption off in many cases by coming up with a standard drawing format that we can provide to the state for evaluation. And if I miss any of this, Logan, well, why don't you just explain what this is? So you know it better than me.
This partial exemption speaks to the energy envelope. This is something that comes straight out of the IECC. So it's an international code. You can normally apply for this in pretty much any state. It gets you out of the energy envelope in regards to insulation values and occupied spaces. So you have an extra, what is it, C402.1.2 is in the code, and it gives you a list of 5 parameters you have to meet. Building's got to be under 500 square feet, under a certain what do we have there? Watts loss. And then there's like special coding that you have to apply to the building for reflective, and then you're out of the com check per se in the energy envelope with this building.
That just gives you a drawing. This is what we would use to send to each state board to apply for exemption. So we came up with the standard, and it has seemed very handy, and it works extremely well. Once you explain the application, generally the need for all of those things that I talked about at first kind of go away. And this is an example of that section that I called out in 2 slides before of an exemption with an S or U occupancy. So utility, we fall under that with electrical equipment. We wanted to list some tools in this as well. Again, we'll do this due diligence for you, but if you need to do some of that yourself, International Code Council, that's where all the codes are for each state and has each typical building program. Also, it might have some special building requirements within each state. Up codes, which is another code, state by state code code checking website. And then ComCheck, I'm not sure you guys will do ComCheck much. We use it all the time, but you can click onto that and it'll take you to the ComCheck website, and it'll show you the things that we have to go through to meet the ComCheck. Things like lighting, HVAC, insulation, building construction, and solar loading in some states. So typically waste heat is not a factor on ComCheck, but it allows you to evaluate your insulation system, and it'll give you a pass-fail pass-fail criteria. And then if you pass, you basically print that report off and send it in to the state as part of your certification packet. An example on that is thermal bridging on metal walls. If you remember, way up in the presentation, I showed an example of an overlapping wall. So you're going to have metal contact on that wall, and in a high solar load, that heat's going to transfer in to the interior of the building. And in some high solar loads, high ambient states, that's when you're going to require a thermal break, which is a piece of insulation on the inside of the wall before you have an interior scan. That's what things like the ComCheck helps check for. Okay, and none of those things are a deal breaker, but it's good to know them ahead of time. Okay. So essentially, and we're getting up to 10 till, I've told you pretty much all the technical information that I wanted to share. Really, the balance of the presentation is just pictures to give you ideas on applications that you can use buildings on. We've taken some renderings and pictures from projects in the past. You can do multiple room buildings for remote sites. We did a control station for a gas company. You can see desks set up in there. This is on the left-hand picture. You see desks set up in there with receptacles so you can sit in there and plug in laptops. There's a kitchen break room in there with a bathroom, and then another control room in here. We'll do dual class buildings for gas applications. So you got Div 1 class 1, Div 2 on one side and general purpose on the other side with an air break in between them, vented. We've done that. Air compressor buildings, drive and control buildings. You can see all the drives mounted on the wall in there with the server stack. We've done a lot of pump control. This is odorant control for mercaptan in a gas application. But you see there's 8 pumps in there with a bunch of stainless steel tubing and piping to handle the odorant supply. And we've done this in other applications as well. That just gives you, this is a model with all the walls taken out, showing all the piping in there. Picture of one of our Dobes. This was on a data site application. We've done them for Microsoft all over the country on their double-ended medium voltage substations. You can do them on control as well. That gives you a great example how the building comes in one piece and gets set. This is a non-walking enclosure, so it gets set on the base. Project we did, nuclear, out in Arizona. Probably our single hardest project we've ever done. 315 by almost 60 feet long. The largest and heaviest buildings we've ever built. This is the one where we had to get the 5,000 hour salt spray test exemption because all the cooling towers, even though it was in the middle of the desert, all the cooling towers were salt solution. So that's in a constant salt spray environment. Had triple redundant 100-ton air conditioning in it, 9-inch thick walls for all the desert, high ambient situation. Some blast panels that you see on the side, and then the air conditioning system. All the ductwork was built in the plenum that the building sits on. So we basically built a base for the building to sit on, and then we housed all the air conditioning ductwork with all the venting and dampers inside of that to provide a closed package.
Was that a stainless steel building, Jay?
No, it was not. We promoted stainless steel. The walls and roof were galvanneal, and the base was mild steel. But like I said, we put our 2-part epoxy paint process to that 5,000 hour salt spray test. So to get approval, from our customer, but it was galvanneal construction. We can do stainless steel, but this was all galvanneal. Transit application. This is a good picture showing how they're kind of craned and slinged in there, going by the track. So LA Metro is a large customer. Put a lot of control stations in for them. Multi-section building is another LA Metro. By coincidence, 24 by 100. You can kind of see it going in at site. It's a good picture. Gives you size and scope. Equipment access doors down along the outside. For example, in California, we put steel tubing all up around surrounding these doors. So basically, this was a structural element without these doors in there. This whole wall can be removed if needed. for equipment access to change equipment out 20 years down the road. And then this shows a building on pedestals along the Mississippi River. I think I'm getting close to the end. Yeah, that's it. So I have other pictures, examples, ideas. If anybody that needs that, Michael, you have this presentation. You might have our specification, but we'll get that sent to you in case you want to distribute that among the group. And then with that, I guess I'm finished and I'll take questions, and I got done within the hour. So.
You did very good, Jay. Great job. Do have a couple more questions. One of them is, do you have a relationship with all of the medium voltage switchgear manufacturers? Do you provide buildings to them?
Yeah, pretty much everybody but Schneider. And we don't have anything against Schneider, but they don't call on us much, so we don't get much exposure to them. That's not to say we can't put their equipment in a building. We just don't have much relationship with them. We have relationships with ABB, Eaton, GE, well, GE's, ABB now. A little bit with Siemens. A lot with Rockwell and Allen Bradley. We don't do as much OEM work as we used to. That used to be our core business, quite honestly. But we started talking to guys more like you and the group that's on the phone to do that business more direct. But we are qualified with many of those OEMs.
Sure. Could you please explain how the roof is sealed when attaching multiple sections?
Yeah, we make, that's a great question. Generally, we use our welded truss system as a header that bolts from the inside to create that mechanical strength. In some cases, you need additional floor supports. But then we'll make a rain cap slash, yeah, no, I'm losing my flashing system is where I'm going. We make a set of flashing that applies to the walls and the roof. And the roof cap has almost got like a standing seam look to it with, a roof cap on top of it for, to prevent water from getting in there. So we don't, most multi-section buildings, we don't have a problem with that. We can give a concept sketch example too, if they need that.
Well, Jay, I think it was great. It was informative. I know I learned a lot. I'm sure the folks in the audience are grateful, and I'm sure we'll be contacted with some opportunities. So thank you so much, and hope everyone has a great afternoon and stay safe.
Yep. Thanks for letting us participate. Appreciate it. Everybody have a great day.